function of preparation. The same exact thing applies to me as does to you. Just like I say to you guys, you know, these do-its, the quizzes, the homeworks, the lessons, they all combine to prepare us for what's expected of us. How do you think you would do if I made up questions for you to do that had very little to do with the kind of questions that are going to be on the final or that are going to be on the state assessment test or that are going to help you for next year? Don't you think you would struggle? So just like your performance is a function of your preparation, my performance is likewise a function of my preparation. You know, one of the ways in which I really learned that, were you guys here when Coach Kelsky taught when you were sixth graders? Was he the gym teacher, Mr. Kelsky? Short little guy, curly hair, high-pitched voice? Who was your gym teacher in sixth grade?
My same gym teacher that's now.
Mr. Padalecci or Miss Farmer?
Miss Farmer.
Did anybody have a guy gym teacher in sixth grade? Who'd you have?
Mr. Gensel.
It was Coach Gensel. Okay. Kelsky then was the year before you were here, was his last year of teaching. He was a phenomenal influence on me. He was a New York State Coach of the Year as far as a wrestling coach. He built our program into a powerhouse. So I remember my first year of coaching, my team was like 4 wins or 5 wins and no losses in the middle of the year, and I started having these delusional dreams of going undefeated. And we had to wrestle a team named Brentwood South. Brentwood South was coached by a guy named Warren Walker. Warren Walker was such an amazing middle school coach. He's the only middle school coach that I know of who was ever written up in Sports Illustrated magazine for being an incredible coach. Our team was set to wrestle Brentwood South on a particular day. And I thought that at the time I was coaching at Saxton, and in Saxton, underneath the gym, there are these like hallways and catacombs where you can yell and your voice will echo. And the first few matches, I would just go down there before the match and I would yell and scream and holler and get the guys psyched up, and we would run into the gym and we would beat up these other teams. So right before the Brentwood South match, Kelsk said to me, he said, "Hey Bob, who do you have coming up for your next match?" I said, "Brentwood South." And he goes, "Oh boy." He said, "If I was wrestling Brentwood South, I would make sure that my kids knew how to counter cross-face cradles, far side cradles, head into side cradles, and single leg takedowns." And I remember, because I was young, saying, "So what? All I got to do is go down to the basement and yell, scream, holler, and we're going to run into that gym and we're going to be so psyched up, nothing can stop us." Well, we went out and wrestled Brentwood South that day. They never yelled. They never screamed. And we lost 61-3. We got annihilated. I learned Kelsky knew something I didn't know. I didn't prepare my kids for how they had to wrestle that day, and we wound up getting crushed. And I learned that preparation was so much a function of performance. So I started listening to Kelsky a lot more, and then a year or 2 or 4 straight years to learn so much of what he knew. And then I also wound up becoming really good friends with Warren Walker. And we would scrimmage every year with each other, and I was the only team he would scrimmage against. And I started to learn his techniques, and I learned Kelsky's techniques, and I learned the habits of the teams that I was going to go up against and coach against. And all of a sudden, we started winning like 8 out of 10 matches every year, 9 out of 10. Then we started going undefeated. And then kids that I coached in middle school were going up to the high school. And in the high school, they were becoming county champs and state champs, and they were going to college on scholarship. And the reason is because Coach Kelsky taught me the importance of preparing for your opponent. And that's really what we're doing with these kind of questions. I'm looking at the kind of things the state likes to ask, the final exam likes to ask, and they help teach the content of the material. And yeah, we still laugh and joke. You guys know that, and I think we have fun in here. But there's always an eye on what we're expected to get right. And we always are ready for that sort of thing. Okay, number 1. Triangle has sides with lengths 6, 8, and 10. Is this triangle a right triangle? Why or why not? How are you going to be able to tell if this is a right triangle? Mike? That's right, by doing the Pythagorean theorem. So, what we're going to do here is Write out the Pythagorean theorem. What does the Pythagorean theorem say? Leg squared plus leg squared equals what? Hypotenuse squared. Sometimes they say a squared plus b squared is c squared. We'll deal a little bit more with that later. Hypotenuse is always the longest side. So 6 squared plus 8 squared is 10 squared. Is that true? What's 6 squared? 36. What's 8 squared? And 10 squared is 100. What's 36 plus 64? 100. 100 does equal 100. Yes. Therefore, this is a right triangle. Any question about that? So here's how they might make it on a state test or on a final exam. They'll say to you, hey, we got a particular triangle and the sides are, and they'll give you 3 numbers. They'll say, is it a right triangle? And all you have to do is write leg squared plus leg squared is hypotenuse squared. The biggest number goes in for the hypotenuse. Check and see if it works. If it works, yes, it is. If it doesn't work, no, it's not. Is there anything difficult about that? Have you noticed how I usually do the do-its a couple of days in a row, and then they find their way onto a future quiz? Have you noticed that pattern yet? Okay, so when you take quizzes, a lot of the time, not all the time, but a lot of the time, I slip in 1 or 2 questions from recent do-its to make sure that you are able to do these the right way. Okay, next, what is the image of the point 3, -4 after a dilation, a scale factor, I should say, of 4? What are we going to get on that? Jennifer, what do you think? What is, we start with the image of the point 3, -4. We do a dilation scale factor of 4. What's my image? No. Guys, what operation do we always do when we see the word dilation? What does to dilate mean? We talked about the definition of dilate the other day. Remember your eyes dilate? Right? Come on, talk to me. What does dilation mean? Well, I'm not worried about, don't tell me, just in general, not math. We're not talking about math right now. Just the English word, dilate. What happens when something dilates? What changes? Think about when your pupils dilate. What changes? Stop.
The size.
The size. To dilate means to change size. So, when we dilate, remember when they dilate your eyes, you go to the eye doctor, he puts the drops in, and all of a sudden your eyes go really wide, and then they're like hard, you can't look at the light because your pupils get so big? Well, the operation that changes size is to multiply. So when it says here, a dilation by a scale factor of 4, what do you think you're going to multiply by? 4. So 3 -4 becomes what? What's 3 times 4? 12. -4 times 4? -16. So I get 12, -16. Guys, I got to tell you, I'm a little disappointed on that one because we've done a number of those over the last few days, and that, to me, is a really simple, straightforward kind of question. Let's do one just on the side here. This means a dilation by a scale factor of 3. And let's do that to the point 5, 1. What am I going to get? Dilation, scale factor of 3 to the point 5, 1. Leah, what do we get? 15, comma? 3, good. So I think we all see that it's very easy as long as you remember that you have to multiply. Okay? All right, number 3. What is the image of the point 2, 5 after a reflection in the x-axis? So let's go to 2, 5. 2, 2, 4, 5. There it is. Now, I want to reflect this in the x-axis. Now, which one's the x-axis? Everybody hold your hand up. Show me which way the x-axis goes by how you move your hand. That's right, horizontal. Okay, so I'm going to flip over the x-axis, which is here. So that would be, oh, what were those 2 words I told you to never forget when you do reflections? Something and something. Oh, come on now. Work with me, ready? Where are we here? Reflect. Look, when we do dilation, we have to remember to multiply. When we reflect, we have to remember to count and repeat. Now listen, if you didn't get that right, you're not working hard enough. Because we both know that if I dropped a $20 bill on your desk yesterday, and I said to you, you come in tomorrow, and I'm going to say reflect, and you remember count and repeat, you can keep that $20 bill. How many people would be $20 richer right now? Come on, Middledorf's honest. Lizzie's honest. Yeah, absolutely. Every one of you can remember count and repeat. Okay, so I'm going to reflect over the x-axis, which means I'm going to count the distance to the x-axis, and then I'm going to repeat. Ready? 1, 2, 3, 4, 5. Then what do I have to do? 1, 2, 3, 4, 5. There it is. So 2, 5, if I'm going to reflect over the x-axis, and this is what we were doing yesterday near when the bell rang. If I'm going to reflect over the x-axis to point 2, 5, what was the result? 2, 5 becomes what? What is the answer down here? What are those coordinates, guys? 2, negative 5. Now, one of the things we spoke of yesterday was we said, well, what's a general rule for reflecting over the x-axis? Whenever I do a general rule, instead of using numbers like 2, 5, I use x, y. Now, let's look at what happens here. The 2 becomes a what? Watch me now. 2 becomes a 2. 5 becomes a. So if what happened to the first thing? The 2 what? Stayed the same, right? So then x should become what? X. It stays the same. Now the 5, Mike, the 5 became what? Negative 5. So the y should become what? Negative y. And that's my general rule for flipping over the x-axis. xy becomes x negative y. I could use that rule like I could if I wanted to. I could say, what would be the reflection over the x-axis of the point 1, 3? And just following the rule, it would be 1, negative 3. Or I could go over here and plot it. I could go 1, 3, and then do 1, 2, 3, 1, 2, 3, count and repeat, and I could get 1, negative 3. So those are two different ways to do the same thing, but we do want you to be able to generalize a specific point into a general rule. Okay, now this time it says reflected over the y-axis. So let's do count and repeat again and see what you get as the reflection over the y-axis. If I count and repeat, I go 1, 2, and then what do I do? 1, 2. And what are the coordinates of that point? Negative 2, comma what? Positive 5. Right? The y is up here. So the y is there. Now, so we could say if we reflect over the y-axis, the point 2, 5, I get negative 2, 5. I realize I'm blocking the view a little over there. 2, 5 became negative 2, 5. So let's write a general rule now. If I reflect over the y-axis, point xy, so the 2 became negative 2. So what happens to the x? It becomes negative x. The 5 becomes 5, so what happens to the y? Stays the same, becomes 1. So there's my general rule for reflecting over the y-axis. Okay? Does that make sense? Okay. Now, let's go to number 4. It says in the space below, graph the line y equals 2x plus 2/3 x plus 1. So if I look at this line, little nice review here. What's the slope, everybody? 2/3. What's the y-intercept? 1. So I begin at 1, then I go up 2 over 3, up 2 over 3, up 2 over 3. I'm going down so this way. And there's my graph. Okay, now notice I can make a triangle as part of that graph. And to go from this point to this point, I could say, look, I have a ratio of 2 to 3, right? Because I went up 2 over 3, and there's my ratio drawn. But then it says something interesting here. It says, I'll show you some similar triangles and some dilations that might not be so obvious. Well, check this out. Here's a similar triangle. How tall is this side? Folks, how tall is this side? 4. And how long is this side down here? Not 4. 6. Right? Isn't 2 times 2 4 and 3 times 2 6? Okay? Another way to look at it, if I check the proportion, little is to big, 2 is to 3. as little is to big, 4 is to 6. If I cross multiply, I get 12 equals 12. And that's a sign that when the sides are in proportion, that they're similar figures. Here's another one, ready? In this case, I'm gonna get 6 and 9. So watch the pattern, 2, 4, 6, then what? 3, 6, 9. Anytime I follow the slope from one point to another, I can create similar triangles. Blue slope, green, it's the same slope, that constant rate of change produces a constant series of similar triangles. I could go from here all the way up to here, all the way down to here, all the way over to here. Watch this. 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 15. And then as far as going up goes, I'm going to go here, which is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the height would be 10. Look, 2 to 3, 10 to 15. Can't you take 10 to 15? Oh, 10 to 15. Doesn't that reduce to 2/3, guys? Right? So it's the same either way. And I can just create more and more and more similar triangles by taking the red triangle and dilating it, multiplying it by 2, multiplying it by 3, multiplying it by 5. That's one way to look at it. Or just by following the slope. So by following the slope from point to point to point, you actually create dilated triangles of the original one. All right, now, do a little bit more work on this reflecting stuff. With a person you're sitting around, I would like you to start this question. Let me cut the size down here a little bit. Let's go to 100%. Good. So what I would like you to do is graph triangle ABC with these coordinates. Then let's see you reflect it over the y-axis, call it triangle A prime, B prime, C prime. Make sure you label it on your graph, and then write the coordinates. So let's see you do parts A, B, and C right now, and then after A, B, and C, I'll take a look, and we'll see how part D works. Okay? Work together. Okay. So I graphed the triangle. I did part A. Everybody looking here? Then we're supposed to flip it over the y-axis. And Lizzie, I'm looking at yours, and it looks like you reflected over the x-axis. It's a beautiful reflection of the x-axis. It's just not the right axis. All right, if we're going to reflect over the y-axis, what are the words I remember every time I do a reflection? Count and repeat. Earn that $20. What are the two things we always remember? Count and repeat. Over the y-axis, so this is 1, 1. That'll be A prime. 1, 2, 3, 1, 2, 3. Kind of like counting. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm such a lame dancer. Ready?
I'm terrible at dancing.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. When I was in high school, the only dances I would dance with the girls were the slow dances. Because then you could just kind of sit there and go. I can do that. Okay, so there's my reflection over the y-axis. And the coordinates would be, let's see, let's write down A, B, C. And then let's write down A prime, B prime, C prime. So ABC was -1, 2, -3, 5, -5, 4, and they became 1, 2, 3, 5, and 5, 4. By the way, what would happen to XY? What would I get? Well, let's look first. Do either of them stay the same? Which one stays the same? The Y. So Y stays Y. What happens to the X? Changes sign. The way we write changes sign is minus X. Okay? All right, so now the next part says, and there, by the way, that's what I just did there, write the rule. The next part says do the same thing, but this time reflected over the x-axis. Some people are a little ahead on this part. Okay, let's reflect it over the x-axis. Go ahead.
You sound like my dog.
Kids call me Chewbacca.
Yeah. That's also like my mom when she's snoring.
Interesting.
She sounds like a horse.
Women don't snore. Just ask them.
My mom sounds like a horse. She goes like this. So that's truth be told. Women do snore sometimes.
Yeah, my wife denies it all the time. She also says she doesn't fart. But okay. I read a thing that says every person alive farts 12 to 15 times a day or more. So, and that
Don't
includes
feed
you,
my brother.
Annabella. Now, here we go.
Feed my
Ready?
brother beans, that would
I'm
be-
going to reflect over the x-axis. Here we go. Ready? 1, 2. Then what do I do? 1, 2. So that would give me a double prime this time. B would go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. B double prime. Now 1, 2, 3, 4. 1, 2, 3, 4. C double prime. Now let's write the coordinates down here. A double prime. B double
It looks like a
prime.
flower.
C double prime. So if A is -1, 2, what's this answer down here? Well, what's A double prime? What's the coordinates? -1, -2. -3, 5 becomes what? -3, -5. And -5, 4 becomes -5, -4. So what does XY become? Do either of them stay the same? They gotta look at these two here. Do either of these guys stay the same? Yeah, the first one, so it's X -1. Okay. Hasta la vista, vaya con Dios, toodaloo, ta-ta.
That I didn't get snoring, but I do scream.
I thought you were gonna say I
Laugh.
don't snore, but I do fart.
No, I don't snore, but I do scream, laugh, and stare at people when I'm snoring.
You do like what the puppies do when they bark in their sleep?
No, but it's a lot creepier for me.
Okay.